Hey everyone, thank you guys for coming back to BayTutors Intermediate Advanced Coding Camp Day 4.
And we have a lot of exciting material prepared for you guys, and we're excited to teach you guys.
All right, so with that, we're going to go ahead and begin our lesson. So today, we're going to go ahead and start off with simple I/O, input-output in Java, and cover the scanner class. Then we'll be moving on to file reading and writing in Java, and then we'll be covering some inheritance in Java, and then completing with interfaces in Java. So today's lesson is going to be quite lengthy, so just stay in there as we'll be covering the lesson right now. So the first thing we'll be talking about today is simple I/O and scanner in Java. So what is I/O? So I/O stands for input and output, and it's basically the input and output of a program's data. And it's basically when you give it an input, sort of like in the form of a text or another data type, then the program will handle the input, and then it'll go ahead and present an output. So that's what I/O is in Java. And an example of an I/O is the scanner class. So the scanner class is one way to receive user input and also present corresponding output. And just like any other class, the scanner class has its own objects, right? Since it's a Java class, and those objects can be instantiated, therefore to receive certain user input. And I'm sure most of you will be familiar with the system class, as you have used the system class for printing statements by using the system.out .println. So the system.out essentially is what you use to provide an output. And similarly, as there's an out, there's also an in. So the system.in is what you'll be using to take an input. And these system.in and system.in is actually utilized by the scanner class and is passed in to the scanner class's constructor to sort of allow it to take input from the system. And the scanner class is part of the java.util package. So in order to be able to utilize and access the scanner class, you need to import the java.util.scanner class before. So you basically have to import the java.util package and specify the scanner class. And you can do that by this statement. So this is importing java.util, the package, and the class name, which is scanner. So after you go ahead and do this import statement, then you'll be ready to start using scanner in your code. So after you go ahead and import the scanner class using the java.util method, then we can go ahead and create the scanner object. And in the scanner object, as part of the constructor, we're going to go ahead and pass in the system.in object as the constructor parameter. So as you can see over here, we are creating the scanner object, right? An instance of the class, the scanner class, and we're going and passing the system.in object as the constructor for the scanner class. And essentially what that does is it tells the scanner object to look at the system.in object for all of its input. So for all of its input into the scanner class, for this particular scanner object, it's going to be looking at the system.in. It's going to be looking at the input coming into the system. And that'll basically be its constructor. And some example statements of how you could use a scanner class in Java is, for example, you could probably declare two instance variables like this: integer age, string name. And then after you create this object, which is already created over here, then you can go and say age is equal to sc.nextInt. So what that means is when the user enters in, right? So when the user enters in the data, right, the scanner will perceive that data as an integer. And the next one is sc.nextString. It'll be looking at the next thing that's inputted, and it'll be taking that in as a string. And it's good to practice to provide and also it's good practice to provide a prompt for the user before they enter a value. So sort of instead of just keeping a blank text field open for them to type in, it's important that you provide them a prompt, sort of such as like enter your name or enter your password and so on. So it's good to provide a prompt. So now that was sort of like a simple demo of how the scanner class works. So that was just, this is like a brief overview of how the scanner class works, and now I'll be giving a quick demo in code of how the scanner class will work. So now I'll go ahead and navigate over to my Eclipse, and you all can feel free to open up Eclipse as well and follow along with this demo. All right, so over here on the left, I've created a sign up class. It's a class that I just created real quick. And essentially what it is, it's a class that takes in, it has these 4 instance variables: name, age, email, and password, something that is usually consistent with every single sign up method out there. And in my constructor, I'm taking in also the name, age, email, password, and setting my instance variables to the parameters, to the value of the parameters. And then after that, I'm just creating a simple getter method, right? That returns a string of essentially all the information about the current user. So for example, if I were to say get info, right, from the sign up object, it would return to me the name of the user, the age, the email, and the password correspondingly. This is sort of how you can implement this. So this is the class that we'll be using, sort of like this will help monitor how the scanner class will actually work. So we'll be using the scanner class in accordance to this class. So this is just a quick overview of how the sign-up class looks. So now we're going to go ahead and start with our first demo for today, which is the scanner demo. So just a quick implementation of how the scanner sort of works in Java. So the first thing, as we mentioned over here, is we have to go ahead and import, right, java.util.scanner to actually use the scanner class. So in order to do that, we're going to go ahead and import it before the class implementation. So we're going to say import java.util.scanner. And as you can see, the import statement's over there, and now we can go ahead and start using the scanner class. So the first thing we're going to do actually is we're going to go ahead and create instance variables here itself. Just like string name. So it's sort of the same ones that we're going to use. Sort of the same ones that are used here in this class. We're just going to replicate that in our main method. So we can go and create an int age, our email, as well as our password. And now we can go ahead and create our scanner object. So we can go and do that by saying scanner sc, give your object any name you'd like, is equal to new scanner. And over here, we're going to pass in, as I mentioned over here, we will be passing in the system.in object. We're going to go and pass in system.in. And this lets the scanner object know that its input will basically be from the system's input. And now what we'll be doing is we can go and create a set of prompts, right? As I mentioned, it's always good practice to provide your user with prompts before they enter a value. So now I can go and create a bunch of prompts. So let's go and say system, print out some prompts right now. Let's just go and say enter your name, right? And after the user enters their name, right? So this is going to prompt them enter your name. So after the user enters their name, right, that input value, the name that they enter, we want to go and store that input value in a variable. So therefore, we're going to say name is equal to sc, right, the object dot next. And what that does is sc.next essentially picks up, right, whatever is the next input that is there available. It's going to go and pick that up. And if you notice, it's if we go back to the autofill, it's actually a string. So sc.next will return a string of whatever is inputted. So suppose even if you were to input like 3, the 3 would be like even if you were to input like a number, it would be interpreted as a string through this sc.next method. So that's what we want to do, right? So after we enter your name, the input value sc.next will be stored into the name variable that we declared over here. Next, we want to create an age. So let's just go ahead and copy this print statement. Let's just go and say enter your age. And now, since we're entering an age, right? Age is we want our scanner class to interpret the age as a number, not as a string. So therefore, we're going to say age is equal to sc.next int. As you can see here, it says int. By doing that, we'll go ahead and store the numeric value that's entered for the age as an integer. Next,
and again, like Nanu mentioned earlier, it's important to have that prompt so that like the user knows what type of thing to input, like so that they don't accidentally input like a string instead of an integer. So having that prompt is very useful, like Nanu said.
Yeah, and you'll actually see how those prompts actually work after you finish implementing this. So now we'll just go ahead and put in our email and our password, right? Those 2 prompts. And correspondingly, we can just say password, right, is equal to sc.next, right, since it's a string. And then we can say email is equal to sc.next, right? So through this, we can actually see that the scanner is going to be taking in all these values. And now we can actually see how this will work in Java. So now we go and click run. As you can see, we'll get a prompt that says enter your name. So when you just go here, let's go and enter my name. Enter. Let's say now enter your age, let's say 15. Then enter your email, let's just say test@gmail.com. And then enter my password, let's just say ABCD123. And after I do that, it's done, right? There's nothing left to enter. So after this is what the scanner is, because after here, it stops, right? There's no more prompts, there's no more me saying sc.next, right? The sc.next is like requesting to take in the next one. But right now there's no more sc.next and there's no more prompts. So basically here, this is where the scanner sort of ends. However, what I was planning on doing is, how can we use the scanner, right, to sort of integrate that with our signup class? And we can do that by doing this. Let's go and create a signup object, right? Let's just say signup user is equal to new signup, right? And to this, let's actually pass in this name, age, email, and password. So after I enter all this information through the scanner, that information will then be used to construct the signup object. And then we can go and print out, once we construct this object, it's going to print out print line user, right? The username object dot get info, right? Using this get info method specified over here. So what this will essentially do is it will go ahead and print out all our corresponding information. So now let's go and restart this. It will go and re-ask us all the prompts again. And then at the end, once we finish with the entering the password, it'll go ahead and print out all the corresponding information. So let's just say information. Let's just go and do this real quick. Right, and then we can just add a blank line here. Right. This just creates a blank line, just like another enter. All right, so now let's go ahead and run this right now. First thing, enter your name. All right, let's go enter my name. Enter Arnav's name right now. Arnav, let's say he's 15. His email is arnav@gmail.com. That's not his actual email. And then enter your password. Let's just say his is like ABCDE1234. Now when we click enter, we can say information. His name is Arnav. His age is 15. Email is ABCDE. Oh, I think something went wrong here. Oh, yeah, sorry. So over here, as you can see, I mixed up email and password. So let's go and swap that real quick. There we go. That's better, right? And then just add another line, new line creation over there. So this should be a little bit better. Let's try this again. So let's go and pass in Arnav 15. ABCD 345. Now when we click enter, as you can see, his information, his name is Arnav, his age is 15, his email is arnav@gmail.com, and his password is ABCD12345. That's exactly what we provided over here. So what it's doing, right? It's storing all the input values into these specific variables: name, age, email, password, and then we're going to go and create our signup object using those variables that we created. As you can see, when we go and print it out, right, user.getInfo, it's able to provide all this info. So that's sort of how the scanner class works in Java. So hopefully that was a little bit clear for most of you. If you guys do have any questions, please feel free to ask them in the chat. Okay, so I think now we can move on to the next thing, which is going to be file reading and writing in Java. So as mentioned before, we can read input with the scanner class, right? Just as we did in the coding demo. Like we read input coming in, right, from this console down here, right? We entered input in the console, and then the scanner class was able to read it and then handle that input and provide an output. And just like that, instead of reading, right, from the console, scanner classes can also be used to read from a file. And reading a string, right, with the scanner class is really helpful when trying to like, separate words or just read input in general. And it's usually used when like saving or loading games. Like every time you restart it, like every time you want to load a game, like for example, if you were to make a game in Java, then you can use the scanner class every time when you're saving the game or restarting the game to like save all the info inside the text file and then load up the text file every time you save or load a game. And also, the scanner class utilizes a variety of methods. And as you saw in the previous demo, we just used the .next and the .nextInt demo, but there's plenty of other next methods, but there's plenty of other methods available that the scanner class has to offer, and you can view all of them at the API. So if you're going to view the API right now for the scanner class, and this is sort of how we use, we'll also talk about how to use API in the last lesson. So if you actually scroll down to the methods, or if you look at the constructors actually real quick, we can see that we can pass in a file source as well as a string and an input stream. The input stream was sort of like the system.in. And the file source is what we'll be looking at right now, coming up. And if we go down to the methods, we can see all the various methods that it allows us to use. For example, the .hasNext method returns true. It returns a Boolean if the scanner has another token in its input, right? What that means is if there's another value for us to take in from the input. So if you were to read a file, right, and there's a bunch of lines, what the .hasNext would allow us to do would tell us, is there another line with input in it for us to use? That's really helpful if you want to like read a text file all the way down to the bottom, like read all the stuff, or if you want to like loop through something, it's really good to use this hasNext method. I mean, as you can see, there's a lot of methods down here. There's also the .next method which we used, right, which returned the string. Doubles, right, .next double, and so on. So highly recommend for all of you to check out the scanner class API and just APIs in general. Just make sure that all of you are just looking at APIs. All right, so moving on. So now we'll be going over reading input from a file using the scanner class. And reading a text from a file is sort of similar to reading input from a keyboard, right? You still will use the same .next method, .hasNext methods and all of that. The methods will stay the same. The scanner class will stay the same. However, in order to read that particular file, you have to make some imports. You have to import some new classes, as well as deal with something called exceptions. So first thing you have to import is the file class. The file class is basically a holder class that can take in a string, right? That represents the path of the file on your laptop, right? The path of the file on your computer. And ensure that this path, right? There's two constructors for this file class. There's two ways of implementing that file class into your scanner object. So for example, the first demonstration is this first line, the first way you can do it. So you can see it's scanner sc is equal to new scanner, right? That's your normal object implementation. And then for your constructor, you're gonna create a new file object and then pass in the text file, right? Because files that you'll be reading from are generally text files. So you're going to go ahead and pass in the name of the text file that you'll be using. And the text file has to be in the same directory as your running Java program. So make sure that it's in the same directory as your running Java program. So that's one way to do it. However, if your file is not there in the same running program, then you can go ahead and create another file object, or you can do it the same way here. But the second way of doing it is just to create a new file object, right? File f is equal to new file. Then here you can go and put your path to the file. So it can either be the same file.txt, or if it's in another directory, what you can do is just put in your full path, right? If you're using Windows, it'll be like C, C \users and so on. Or if you're using a Mac, it'll be like documents / blah 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 and so on. So these are two ways of doing it. And then after you create this file object, right, with the path, you can go ahead and create a scanner, new scanner object, and pass in that f, right, this file object. Either way, you're still passing in a file object as your constructor. So these are two ways to do it. The first implementation is more concise and something that I believe is just a little bit easier to read. So after you create the file, right, that's going to sort of be the file that you'll be reading or taking in as your input, right? It's sort of like your input source for the scanner class. Then you also have the java.io.io exception, which is an exception. So basically what happens when you're using scanner classes, especially when you're reading a file, is that there's a chance that you might get thrown an exception by the scanner class. And this will usually happen, for example, if that file is not available, or maybe if that file is not there in the current directory, you might get an exception thrown at you, right? It might tell you file not found exception, and so on. So just to be prepared that these exceptions don't get thrown at you and you can handle them properly, is why you use the try catch statement. And they're basically used to handle exceptions thrown by the scanner class or any other class in general. Right? The try catch is a statement that's used to handle exceptions thrown by any class. And there are many exceptions in Java, such as like a null pointer exception and so on. But for this one, since we're dealing with input and output, we'll be just focusing on the IO exception for now. And we'll be covering other exceptions in a later lesson. But for today, we'll just be focusing on the IO exception, since that's what's covered in this particular lesson, since it's considering input and output. So the try catch statement is implemented sort of like the one below. So you try like a try block. Could be useful. You'll pass in like whatever statement you want to be here, whether that's creating your scanner object, passing your file object, and so on. And then you'll have a catch statement, right, which will catch the IO exception. And notice you're creating an IO object over here. So IO exception I. And then you're going to print out, right? In case there's an error, you're going to print out that error by saying I.get message. So I is referring to this object name. You're going to get the message, the error message that's giving you.
Okay. And again, with a try catch statement, it only like executes that stuff within the catch block if it caught an error. If it didn't catch an error, it doesn't do that. And one thing to know about this specific example is that it doesn't actually catch every error out there. It only catches that one specific error. So you have to make sure that if you want your code to be like error free, then you have to like catch the right exceptions.
Yeah, so you have to basically know which exception you want to catch. Yeah. So, but for this one, we'll just be using the IO exception because it'll only be looking out for this exception. Yeah. So that's sort of how. That's sort of like the pre-processing you have to do before you actually write a scanner class. So now, yeah, so that's sort of how you would read input with the scanner class. So you just pass in your file, your text file, for example, and then you'll go ahead and start, using the methods, right, the .next to sort of read that file. So the file will basically be like your input method. So now we'll be going over writing output. So you can read, right, using the scanner, but you actually cannot write output with the scanner class. You have to use a different output thing, which will be called the file writer. Please ignore the header. That is actually an error, so please ignore this. This should be the file writer class, not the scanner class. So with the file writer class, right, it's a class that helps you write to a certain file. And the way you do that is you create a file writer object, right, by saying file writer file is equal to new file writer. And then you're going to go and pass in the output file, the file that you want to write to, right? Make sure that this is not the file that you're reading from, because you want your reading file and your writing file to be two different things. So your reading file will be like an input file, and your writing file will be like your output file. So make sure that you specify a different file right here. And what the file writer file, what the file writer method class actually does is when you create the object and you specify, the file that you'd like to create with the name, it'll actually create a new file for you. So you actually do not need to have the output, the writing file already created. When you actually run this instantiation, it'll actually create that new file for you. And yeah, so basically open a file writer object that will point at the file text file in the same directory where the Java file is run. So we're going to create that in the same directory where your Java file is run. And when the file is opened, one thing to keep in mind is that once you reopen the file, suppose like you wrote like a lot of stuff in the file, and once you reopen it, all the previous data will be erased. So every time you open the file, it'll be a fresh blank file. That's something to keep in mind, since it'll erase all the previous ones. And if you would like to write data to a specific file, you would use the file writer .write method, which essentially takes in 3 parameters, or sometimes you can just pass in 1 parameter. The int are optional, but the string is sort of mandatory. So the string is essentially what you would like to write to the file, so it has to be in string format. I believe there's also a write using just an int, where you can actually write an integer, but for this one, the primary thing is a string, so you'll be writing a string to the file, so that's what you have to write. Next, there's an int, right? The int is basically where in that string you would like to start writing your data. So suppose you have a really long string, like I have a dog, blah, 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 the integer would specify the index in that string for which you would like to start. So suppose like you'd have the string, I have a big dog, then you can choose, right? If you'd like to, it's optional. You could like, maybe like you just want to write from the big dog part. So then you choose the index of b, right, in big, and that sort of be where the start of your string would be, that would be written to this file. And then the second int, right? The second int is basically how many characters from the start you would like to write. So suppose we pick the B, right? The big dog portion of it. Then how many characters would I like to write? So suppose I just want to write the word big, right? Within that string, I just pick 3 because it's just BIG, it's 3 characters. We'll be going more into detail in this in our coding demo soon. So that hopefully that'll make a little bit more sense for you. And just as it is important to open up the file and write to it, it's more important actually to make sure you use the dot close method after you finish writing. So what the dot close method is, it's essentially saving the file so that all the thing that you write is actually written to the file. So make sure that after you write down all your write statements and all this stuff, ensure that you use the dot close method. And also, just like reading a file, you also have to use a try catch statement when writing to a file, just to prevent any possible exceptions, just to like handle any exceptions that are thrown at you. And also about writing a number to a file. Yeah, so it only takes in, using this dot write method, you notice it takes in only a string, right, as the thing that's going to write. So if you like, want to write an integer or something, or like just a number in general, what you could do is you could create a number variable, right, like an integer variable, and embed that within a string, and then go ahead and write that to the file. So technically you'd get a number inside the file. So that was a lot that was definitely a lot on just file writing and reading, and IO in Java. So now we'll be going over a file reading and writing demo using both the scanner class and the file writer class, just hopefully so that I can clear up some stuff for you. So let's go and start off with this demo. So I'm going to go ahead and comment out all this code from our scanner demo. I'll actually go ahead and delete it and paste it somewhere down here. All right, so we don't have to worry about that right now. All right, so let's go and begin. So we're going to go ahead and start with our file reading demo. I have to give an error here. All right, so let's go and start off with our file reading demo. So as I mentioned before, when we're doing a file reading, you have to ensure that you import the java.io.file class as well as the java.io.exception class. We're going to go and do that right now. So we're going to go and say import, let's import this down here, java.io.file, and then we're going to import java.io.io exception. Okay, and now we go ahead and have our both our imports. Now we can go ahead and start with our file reading demo. So now let's go and start. So now we can go ahead and create our file reading demo. So first thing we have to do is, so what we're going to do first is we have to sort of create that file, right? So let's go ahead and go here. Let's go ahead and create that file real quick. We can go ahead and click new file, and we're going to go and create our input file. So we're going to say input for the file name .txt. That's be a .text file. So we're going to specify the file name as input.txt. Right. Once we get that done, as you can see, this is our input file. So now let's go and just write some stuff to this file real quick. So let's just go and say, let's say we want to integrate this file with our signup.java class. Let's go and provide some names. So let's put my name, put an age, let's put an email. So let's just say, let's put a password. Like, once again, let's put like 1, 2, 3. Okay, let's say that's my password. And let's go and save that right here. So now our input file has some text to it at least. So let's go over to our main method. And now we can start with what it is that we're trying to do. So as I mentioned before, let's go and create some instance variables that we'll be using. So let's go and create the same string name, the int age, the string email, as well as the string. Okay. second. I believe I am unsure of what is happening right now. Oh, okay. There we go. Sorry, that was the problem. There was an extra comment down there. All right. So once we create all our instance variables that are similar to the ones over here, we can go ahead and start reading this input.txt file. How we're going to do that is we're going to go and create our scanner object. We're going to go ahead and use the method that we did previously, right? In the new file, right? As if you recollect from over here, right? New file. We're going to go and specify the name. So our name is input.txt. So input.txt. And once we go ahead and do this, but then you'll notice, well, there's an error over here. And the reason is because it's throwing an exception for us. And how do we deal with exceptions? We do that by creating a try catch statement. So let's go and create a try catch statement. So let's go and embed this within the try block. And let's go and create a catch block. IO exception. Create like a object name as E, right, for error. And let's go and print out. In the case that we do get an exception, it's going to print out. Format it by saying error plus E, right, the name of our object, dot get message. Just like that, we've implemented our try catch statement and the error is gone. Let's go and run this right now. And if you do not get any output, right, if you're not getting any exceptions, then you're perfectly fine, right? That means no errors are coming your way. So now that we have this, let's go ahead and start storing our, let's go and start adding some values to our variables. So as you can see here in our input.txt file, our first thing is a name, right? My name. So let's go and say name, right? Let's go and initialize this. So let's say name is equal to sc.next, right? Similar to how we did before. And it's basically the same thing. So now we're going to say age is equal to sc.next int. Email is equal to sc.next. Password is equal to sc.next. As you do this, we're just going next line, right? Each time to see these methods, like, oh, well, sc.next is the same as sc.next right here. But these are actually iterating through the lines, right? Iterating through the inputs over here. So this file is basically our input file, and it's going to be reading this similar to how it read our console. All right. So yeah, so that's how it is. So now we've gone and set values to our name, age, email, and password. So now if we go and just run this again, just ensure no problems are there. Great, so no problems. So now we've stored all these values into our variables over here. So now let's just do the same thing we did in the first demo. Let's go and create our signup object. Right, and now let's go and pass in the same variables that we just initialized. Right, sorry. Okay, let's actually call this user. It sounds better. All right. So there. So now that we have created our user with the information from our input.txt file, let's go ahead and see if the information is actually correct. So let's go and print out how we did before. Information /n to create a new line plus user.getInfo. And now we go ahead and run it. We'll go ahead and see that here our information is my name, Shrinandan, age 15, email is shri@gmail.com, password is 123 ABCD. And if you refer to our text file, which we just read from, as you can see, the information is identical because we read it from this file. So that's sort of how you can read a file in Java using the scanner class. So it's very similar to how you'd read it from a console, except you'd just be, when you're creating the object, you would actually pass in a file with certain text in it as your input. And then you use the same methods, and then you would go ahead and test it out and make sure that you embed all of this within a try-catch statement. That's how you would do reading a file in Java using the scanner class. Any questions on this? If anyone have any questions, please feel free to voice out or ask in the chat. Okay, good. So now we'll be moving on to our third demo, which is going to be, let's go and comment this out as before down here. So now we're moving on to our third demo, which is going to be a file writing demo. So the file writing is what we discussed in our last slide here of our second lesson, which is to use the file writer class, right? And as you can see here, we have to import java.io.filewriter class. Let's go and do that right now. Like that. And now we're ready to start doing our file writing. So as I mentioned before, to show how this would work, I'm going to go ahead and open up my Finder in a second tab to this current directory. And as you can see, this is the same in the same directory as my class, as my BayTutors summer demos project. Actually, one second. I'm going to tile this left. All right, as you can see, we have our classes, right? Main.java, signup.java, our input.txt file here as well, right? So this is the directory of this project. And what I'm going to show you is how, when I go ahead and create my file writing object with the name of our output file, it'll actually go ahead and create an output.txt file over here. So just keep your eyes on the left side of my screen after I finish creating this object. The first thing we're going to do is we're going to go and create our file writer object. So let's say file writer is equal to new file writer. And here let's go and pass in, right, as we mentioned over here, just the name of the file that you want. So let's just go and call this output.txt. That's pretty accurate. And there we go. So once again, we have to embed this within a try-catch statement. So make sure that you put this within a try-catch statement. All right, so let's go and take this line, open this up, paste it in there. Here, let's just go and take this from right down here. Right, so that's the same error message as before. There we go. So now when we go ahead and run this, let's go and see how it works. One second. Okay, the screen sharing is blocking my vision. All right, there we go. One sec. Sorry. Okay, yeah, I just want you guys to be able to see how the file is being created. All right, better. All right, so now, as you can see on the left side of my screen, there is no output.txt file, right? Because we haven't created it yet. So now when I go ahead and run this, you'll go and see that the output.txt file just appeared, right? Because it just got created at 4:44. And now when we go and open this up, it's going to open up this text file. Double clicking, it's empty. There's nothing in it, right? And that's how we want it. So now we're going to go ahead and start writing to this text file from code. It's going to close that, head back here, and now we can go and start writing to our text file. And how do we do that? Well, we use something called the write method. We're going to use something called the .write method. Let's go and test that out right now. So first, let's go and say writer, right? Writer dot write. Let's just write a simple string, right? So say my name is Shrinandan, and I am using, say, the file writer class. Right? There we go. And we said writer.write, okay? And now let's go and close that. Remember, you have to close it after you write your statement. So say writer.close. And now you've gone and written something. So we should expect to see this string, right, in our output text file right now. So let's go and run it. And now it's going to open up this output.txt file. As you can see, the text is there, right? My name is Shrinandan, and I'm using the file writer class. Let's go and close that. And now let's go and add some more statements, right? Let's go and add some more stuff. So let's go and say writer. So just to show you how this sort of works, right? The string int. Let's go and create another string. Let's go and say string text is equal to I have a dog that likes to run around. And that's a string. Now let's go and say writer.write. It's going to pass in the text, right? The text variable as our string. And then now our integer is going to be where in the string do we want to start writing. So let's start at the letter D, dog. So there, let's go and count up the indexes. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's at the 9th index, right, that D is at. So let's go and pass a 9 there. And then now how many characters do we want to write? Let's just say we just want to write like 10 characters. So we want to write 10 characters. So from D onwards, it's going to write 10 characters from D onwards, however much 10 characters is. It's going to write that to our output file. Now it's going to run this. And as you will see, when you open this up, right? Okay, I think it got put on the same line. So to avoid that, let's just create a, let's just add a \n there. And now when we go and write it, you will see, oh wait, 1 second. Oh no, something is happening. All right, 1 second. Okay, so let's go comment this out to show you how that method will work. We're going to open this up. You can see that dog.l. What that is this is actually 10 characters. So if you can count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 characters starting at the letter dog, as you mentioned, from the 9th index and moving 10 characters onwards. And that's sort of how writing to a file in Java sort of works. So hopefully this sort of made sense to you. I know this was a lot to take in a day, but hang on, we're not done yet. So this is just a couple of demos that I had planned for you. You know, starting off with the scanner demo, right? Just taking user input from the console and sort of integrating that into a sign-up object. Then using the same scanner class to read a file, right? Using another file as an input and reading that file and sort of integrating that with a another class, as well as writing to a file using the file writer class to sort of write to an output file like so. All right. So now Arnav will go ahead and start with his presentation on inheritance.
All right, yeah. So inheritance is something that's probably new to you guys. We covered object-oriented programming previously, but this kind of goes more in depth with that. And inheritance is basically when one class extends from another class, and the new class that extends from it inherits all of the properties. And inheritance is really the fundamental to object-oriented programming, and is quite useful when you use it right. So basically, the class that your new class extends from is called the parent class or the superclass, whereas the new class that you make is called the subclass or the child class. And basically, the subclass is like a different class from the parent class, and that class inherits all of the properties from the parent class, but can also add on to that parent class by having its own unique attributes and methods in addition to the one that inherited from the parent. And one thing to note is that inheritance is actually between the classes and not the objects. So inheritance is something that you see like in your code and not the actual objects that you create. So if we look on the right side of the screen, we can see like it's basically a simple visual of inheritance where we have this class person and the attributes name, age, and gender on like for person for the class person. And person is actually considered to be our superclass or our parent class in this situation, since it has these two children, student and teacher. And then if we look at the first subclass of person, we have student, which actually has, in addition to the name, age, and gender attributes, actually has additional attributes such as grade, GPA, and number of classes, which are different from the attributes that the person has, but they're basically like in addition to those attributes that the person class had. And we'll see that in the demo, but for now, that's just something to note. And same with the teacher class, we have more attributes in that class in addition to the person class. So basically that's what inheritance allows us to do, is it allows us to have more detail within those subclasses. And just one last thing to note is that you can actually have subclasses of subclasses. So you can have kind of like a tree where you have subclasses of like these subclasses, and that inheritance can like basically go on forever. And we can see that with the student class having subclasses such as high school student and college student. And we didn't list out the attributes, but they can have their own unique things, which is like helpful to have.
Yeah, so it just really helps you like define a general class and then build up to more specific instances of that class. For example, like if you look at the person, very generic, then there's a student and teacher, And then the student can also be expanded into more stuff, as Arnav said, into like a high school student and a college student. So you can just go more and more specific by using inheritance.
Yeah. All right, so now let's look at the syntax for declaring in like a child class. And the syntax is basically very similar to the syntax for creating a normal class, where we have the keyword public, and then we have class, and then the name of the class, obviously. And then after that, we use the keywords extends. So after the class name, we write extends, and then the name of the parent class. And note that the name of the parent class has to be in the same package or like project. It can't be like some from a different project. It's basically similar to how you would use classes normally. So within the child class, we have all of the new attributes, constructors, and methods that are in addition to those of the parent class. And when a subclass is constructed, we also need to call the parent constructor, and we can do so in the constructor of the subclass by using the keyword super. So taking a look at this example, we have the student constructor, where we pass in the attributes name, age, gender, and GPA. And the first line of your child constructor will actually be the call to your parent constructor. And we do so by using the keyword super. So we do super, and then we pass in the parameters that the super constructor needs, or the parent constructor needed, which are name, age, and gender. And then after that, after we call the parent constructor with the keyword super, we can go ahead and initialize our object as usual by saying this.gpa equals GPA, and that's basically just like standard object construction, and that's all after you call the parent constructor. So essentially, the subclass doesn't have any code from the subclass doesn't actually have any code from the parent class, although we must initialize the parent class and its attributes, and that's pretty important to know. And note that we don't need to rewrite the parent class methods unless we want to override them, which we'll talk about in the next slide. So like we talked about previously, we can have new attributes in the child class, but we can actually also override methods from the parent class and edit them so that they're more specific to the subclass or the child class. So one thing to note about that is that you're required to have the override tag right before the new method that you kind of override or edit. And you don't need to include this if the method is not being overridden or the child class does not include the method. You only need to have that override tag if you're actually going to edit that method or add to it. And you can actually access private variables from the parent class by using the super keyword and then calling the method, as we'll see in the example on the right. So taking a look at this example, we can see that first of all, we have the parent class method, which is called getInfo. So it's just a standard method called getInfo, where we return the name of the person, and then basically just a bunch of info like we looked at in the previous Skinner class demo. And that basically just returns a string with all the information. But then if we look at the method from the child class, we actually override the method getInfo, which is one of the parent class methods, and we use the override tag to actually override it and add to it. So if we look at it, we actually do super.getInfo, which is basically calling the method from the parent class with the super keyword. So basically we're doing super.getInfo, which returns a string, and then we're concatenating that string with new additions to it, such as where we add GPA, and then we add the GPA, and then we add the grade and the grade to the end of it. And that returns a different string in addition to that string that we had from the parent class. And finally, when we're constructing inheritance classes, we can actually declare them as their parent class, but initialize them with their subclass. So this is just like in your main method when you're trying to construct the object, you can actually just say person S1 equals to new student, and that's perfectly like legal, and it won't throw you an error because student is a type of person. So that's actually legal and it won't throw you an error. But although you can do that, you can also just initialize it directly as a student or like the subclass, where you can just say student S1 equals new student. But you need to still ensure that the parent constructor is called within your constructor of your child class. So now we can move on to an inheritance demo in Eclipse. Nando, if you want to stop screen sharing.
Yep.
All right, so previously we looked at an example where we had the classes person, student, and teacher, but we're not actually going to implement the teacher class for the sake of time. So just a quick run through of the person class. It's just a normal class where we
I'm
store.
sorry to interrupt, but we will be going over time today, so please stick behind, just like a couple minutes, maybe like 10 minutes, just past 5, so that we can complete this lesson, as it's really important. Thank you.
Yeah, so as I was saying, we have your standard attributes such as name, gender, and age. Then we have the constructor for them as we would with any other class where we initialize everything to its stuff. So we do this dot name equals name, and we do all of that as we would normally. And then here we just have a list of getter and setter methods. And then finally, we actually have a method called getInfo, where we return the person's info, which is like their name, their age, and their gender. And that's just a quick overview of the person class. But now we can actually take a look at the student class, which is a new class that extends from the person class. So as we talked about in the slideshow, we actually need to use a keyword extend. So we write extends person. And this basically makes it so that it is a class that extends from person. So as we can see, it's throwing us an error right now because we don't have the constructor for the parent class. So we'll actually go ahead and do that right now. So we'll do public student, and then we pass in, as with the person class, we pass in name, age, and gender. So string name, int age, and string gender. And in addition to that, we can actually pass in something like double GPA for the student. And then we can initialize it as usual by doing super dot, or actually super, where we pass in name, age, and gender. And it looks like Eclipse is actually autofilling that for us, which is great. And then as we looked at it, as we saw in the slideshow, we can just do this dot GPA equals to GPA. But we actually haven't created the variable, so we'll go ahead and do that right now. So we'll do private double GPA. And here we're just initializing it as usual. So that's just a quick demo of how you can use the constructor for the child class, where like it's important to note that your first line has to be the call to the parent constructor. Otherwise, it'll throw you an error, and yeah, that's not good. So that's just one thing to know with the constructors. Now we can move on to the methods that we want to override. So if we looked at in the person class, we actually have this method called getInfo, and we can actually override it within the student class. So we can do public string getInfo, and this returns a string as we did with the person class. And if we actually click this error message over here, this is actually just because we don't have a return type yet, but we'll do that briefly. And since we're actually editing the method from the parent class, we'll just use the override tag. So we'll say @override. And that basically tells Eclipse or the compiler that, hey, we're going to override the method. And that's just something to note. So now we can actually return, so for the sake of simplicity, we'll just do string str equals super.getInfo, which is all of the info that we see over here. So it returns the name, age, and gender, and that's just that. And then we can concatenate the string that we get back from the person class, and we can concatenate that with the string that we're going to return here. So here we'll just do super.getInfo plus /n to start a new line. So \n, and then we'll say GPA is that plus this dot GPA. And that's basically just how we're overriding the method, and then we'll finally just return str. And one thing to note here is that we did actually use a super keyword when we're trying to access the method from the super class. So we actually had to use the super keyword instead of just saying getInfo. So now we can go ahead and run our code in the driver class in the main method. So we'll start off by initializing the students by saying person s1 equals to new student. where we pass in all the parameters required for the constructor. So we'll say name is John, age is 15, gender is male, and then finally GPA is, let's say, 4.0. So now here we initialize the student by declaring it as a person, but actually initializing it as a student, which we talked about previously, is actually legal. So that's that. And then finally, we can just print out the info as we saw in the student class. So we'll just do system.out.print ln s1.getInfo. And if we go ahead and run the code, we can see that if we look at the console here, it actually prints out the name, the age, and the gender, and the GPA, which is a student class, which is actually a student attribute. So even though we never like directly had the variables name, age, and gender stored within the student class, it actually was stored in it because it extended from person, and we initialized it with the constructor. So it was able to get that information and print it out and store it. So that's just the demo for our inheritance. That's just in our inheritance demo, and now we'll move on to interfaces.
Okay. Oh, sorry.
Mm-hmm. And one thing, so now we can talk about, sorry, that header there is actually wrong. That should say interface, so just ignore that. And this is supposed to say interface. So an interface is actually not a class, and it's actually just a list of methods that other classes can implement. So similar to classes, interfaces are kind of like a blueprint that other classes can use and implement. So one thing to note is that if a class implements an interface, it is forced to implement all of the methods that are listed in the interface. Otherwise, an error will be thrown, and that's not good. So the general header for an interface is public interface, and then we have the interface name, and then in the body of the body of the interface, we actually just have a list of methods that we want to include. And within the method in the interface, we actually don't have any code for the methods. Instead, it simply just lists the method headers, and it's up to the classes that implement the interface to actually write the code and implement those methods. So if a class implements an interface, we mention so in the class header. So we say public class, and then the name of the class, implement, and then the name of the interface, as we did with the inheritance demo. So on the right side of the screen, we can just see a simple demo of this. So we have an interface called teacher methods, where we have the two methods listed, which are get info and get salary. And if we can, one thing to note is that we actually don't have any code for this. Instead, we just have the method headers and then a semicolon right after that. And then this next thing is we have this class teacher, which actually extends from the class person, like we saw in the inheritance demo. And then it also implements the, implements this interface called person methods, which is this on the top. And I think there's an error on the slide where these two interface names are different, but just note that this should say teacher methods instead of person methods in the down below. So if we can see over here, the class teacher actually implements the methods from the interface, where it implements the string get info, and then here's just a simple implementation of it. And then we also implement the method get salary, where we just return that type, and that's just a simple implementation. And that's basically what an interface is. It's just a list of methods that we can have and we can implement in different classes. All right, so that is it for today, guys. We went a bit over time, but that was a pretty heavy day today. So we actually went over simple IO, and then we talked about file writing, reading, scanner, and then we went into a bit of inheritance and interfaces. And there's actually homework this week, which is a worksheet, which you can access at this URL and submit it using the same submission link.
Yeah, so with that, thank you all so much for joining day 4 of Intermediate Advanced Coding Camp, and we look forward to seeing all of you for day 5.